Recording started.
All right, let's talk about some basic terminology with angles. And the basic terminology with angles is that an angle in standard position, has one side along the x-axis that's called the initial side, and has one side off the x-axis that's called the terminal side. And we are measuring that gap between the two angles, or between the two rays. We call that angle theta. But the thing to remember is the initial side is on the x-axis. The terminal side is off the x-axis. If it's going counterclockwise, that's a positive rotation. If it's going clockwise, that would be a negative rotation. So this is a positive rotation. I'll show you one that has a negative rotation. So if you imagine one here on the x-axis, this angle here would be a negative rotation. If you take an entire circle and divide it up into 360 pieces, each of those pieces are called degrees. So our angle here could be measured in degrees. In this course, we will measure in another unit, and that's called a radian. Let's talk about a radian for a minute. If you picture a circle and look at the radius of that circle, if you take that length, the radius length, whatever that radius length is, and map it out on the circumference of the circle, along the circumference here, so that this length is the same as the radius, that length would be called 1 radian. If you do this over the entire circle, what you'll find is there are 2 pi radians in one circle. So 2 pi radians equals 360 degrees. Now most of the time we're not going to have the word radians, we're not going to write the word radians. So if you see an angle measure that doesn't have the degree symbol, you're going to have to assume it's in radians. Let's convert. Oops. If you're going to convert from degrees to radians, you multiply by pi over 180. If you're going to multiply from radians to degrees, you multiply by 180 over pi. So let's talk about this. Let's say I'm going to convert 90 degrees into radians. So I'm going to multiply that by pi over 180. Think of that as 90 over 1. So 90 goes into 90 one time and into 180 twice. And of course, the degree measurements cancel. So I have pi over 2. When I multiply straight across, I just get pi over 2. So 90 degrees is the same as pi over 2 radians. Let's talk about 4 pi over 3 radians, and we'll convert that into degrees. So I'm going to multiply that one by 180 degrees over pi. And again, pi's will cancel. 3 goes into 3 one time, and one time into 180, 60, which will give you, let's see, multiply straight across, 4 times 60 is 240 degrees over just a 1, so that's just 240 degrees. There we go. Converted from radians to degrees. Now let's do this one. A circle has a radius of 25 inches. Find the arc length of an arc intersected by an angle of 45 degrees. Okay, a lot of new terminology, but let's just think about it for a minute. Here's a circle. Here's the center. Let's think of an angle here of, say, 45 degrees. What I'm looking for is I am looking for the length along the edge of the circle. That's the arc length. And we're told that the arc length is equal to the radius times theta. So that's the setup. Let's see if we can work this problem. First thing we have to do, the arc length, of course, is going to be, or the formula for the arc length is r times theta, where theta is the angle, but it's going to be the angle in radians. So I need to convert 45 degrees into radians. So I take 45 degrees times pi over 180, 80 degrees. Take that as 45 over 1. Turns out 45 goes into 45 once, then into 184 times. So multiplying straight across, I get pi over 4. So 45 degrees is the same as pi over 4. So our arc length should be the radius, which we said was 25 inches, times pi over 4, which was the angle. Pop that into my calculator. I'm just going to get a decimal here. 4 divided into 25 is 6.25 pi inches. So that is the length on the edge of the circle of an arc intersected by a 45-degree angle.